Welcome to the DEEPMED Seminar, a history forum for ocean science, strategy and environment. The DEEPMED Seminar is brought to you by European Research Council funded research project DEEPMED, which stands for Discovering the Deep Mediterranean Environment, a History of Science and Strategy from 1860 to 2020. Today, Peder Roberts will be talking about floating ice islands and Cold War oceanography. Infrastructure in Search of a Purpose, intriguing title. Peder Roberts is a historian of science, technology and the environment at the Royal Institute of Technology in Stockholm and a professor of history of science at Stavanger in Norway. I first met Peder Roberts when we were both postdocs at the ERC-funded project The Earth Under Surveillance, led by Simone Torchetti, and which studied the significance of Cold War for the earth and environmental sciences. Peder had just completed his first book called The European Antarctic, Science and Strategy, again, in Scandinavia and the British Empire. That book confirmed Peder as one of the leading historians of the polar regions, and he expanded his interest from the Antarctic into the Arctic as the IP of the ERC-funded project Greening the Poles, Science, the Environment and the Creation of the Modern Arctic and Antarctic. He has published many articles on books, on the edited collections and so on, and chapters on the polar regions and the role of science, technology, and politics in shaping their environment as well as changing our perceptions of those environments. He very recently, for instance, published the edited volume, The Cambridge History of Polar Regions, which I'm looking forward to read someday. So, Peder, thank you very much.
Thank you very much, Lino, and thank you to everyone for coming along today, particularly you, Sam, as I gather you have far more important things to worry about at the moment and far more important people. So I am really touched that you've taken time to come along. It's much appreciated. So the presentation today derives from some work that I began because it allowed me to go to some archives that were quite distant and spend some time thinking over some big problems. And I'm also very grateful to my employers at the University of Stavanger in Norway, who granted me a 12-month research sabbatical, which I'm in the middle of now, which has been absolutely brilliant and which has enabled me to finally dig into some of that archival material and to try and tease out some conclusions. Now, the presentation today is very preliminary in nature. Partly because I'm still, I think, trying to grapple with the main methodological questions, and partly also because I have a feeling this is an interesting story, but I'm a little bit unsure about exactly how widely I can make the specific points within relevant to broader questions. I tend to be optimistic to the point of being like Icarus flying too close to the sun with these things. And I always tend, I think, to try and make the arguments bigger than they perhaps are. We'll see how this goes. Great. So the talk today will cover quite a bit of terrain, but the main focus will be, just making sure I'm synced here. The floating ice islands that were operated by the US military, particularly during the 1950s and the early 1960s. So I will begin with an introduction to why these ice islands are interesting, some of the background to it. I'll go on to why the military and oceanographers found them important and useful places. Try and couple that to the political work that drift stations did. Then we get to, I think, some of the more complex questions. Just because you had a nice piece of research infrastructure, how useful and important was it actually, both to the oceanographers who worked there and the military who paid for it? And then the big question, which is to what extent can we use the story of these floating ice islands to think about the relationships between funders, researchers, and infrastructure? And that, I think, is the broad question that I'd like to try and grapple with. So I'll start by giving some historical and geographical context. Most of this talk takes place in the high Arctic, in particular the area of the Arctic immediately to the north of North America, above Alaska and above Canada. Now, the Soviet Union was also interested in drift stations, as I'll mention in a moment. This, I'm afraid, is largely a US story. Partly that's because I think the dynamics play out very nicely here. The US, right from the start, I think partly through accident and luck, partly through design, had larger and more infrastructure-heavy facilities than the Soviet Union's, which tended to be a little more basic. And then there's also, I'm afraid, the reason that is obvious to me, but every time is no less embarrassing, and that is my Russian is so poor I could not interrogate that story, even had the archival resources been available, which for obvious reasons at the moment they are not. So perhaps it's worth keeping in mind there is something of a potential parallel shadow Soviet story here. Mine is an American story. It's also an Arctic story in as much as the events play out in the Arctic, but as I mentioned, I am curious to see how, particularly to oceanography, where large pieces of mobile infrastructure, more or less mobile, also play a role. I'm curious how far I can push this argument into other geographical areas. So my own interest here, how can I put this delicately? I didn't set out to look at floating ice islands. I did set out to think about the Arctic. And the floating ice islands have cropped up because what I thought was going to be a simple and linear story turned out to be a little more complicated. Simple in the sense that there's actually a couple of very nice books written about research in the high Arctic on floating ice islands, and they describe very well some of the issues that arose. But what I found surprising was the mismatch between the facilities that were available and what the scientists actually wanted to do or could do. And it's that mismatch that I think is the angle I'd like to try and push. So we'll start with a little bit of historical background. I'm going to use the term drift station on and off throughout the talk today. And when I mention the term drift station, that's a shorthand for a platform, either a ship, a piece of ice, anything that floats through the ocean and enables scientists who are based upon it to take observations and measurements as it moves. There's an argument that one of the original drift stations was the Norwegian ship the Fram, which we see here. The Fram was an innovative ship designed by the naval architect Colin Archer in collaboration with the Norwegian oceanographer and polar explorer Fridtjof Nansen. Nansen's idea was that if you had a ship that had a shallow curved bottom that was suited more to being almost resting within the ice rather than being optimized for sailing through the ocean, the ship could potentially be frozen into the Arctic ice pack, move with the ice as the currents and winds dictated, and without needing to leave the ship would be taken by the ice across the North Pole. Now, for Nansen, this clearly had two advantages. Firstly, he wanted to get to the North Pole. He had already been the first person to ski across Greenland in 1888. That made him a hero in Norway. Being the first person to get to the North Pole would have only enhanced his fame. But he was also an oceanographer. He was genuinely interested in the currents that operated in the high Arctic Ocean, and he felt that a stable platform that would enable measurements to be taken along the way would be useful, in addition to the overall fact that the movement of the ship with the ice would itself reveal something about how the currents worked. So he sets out to put this into practice, and in a famous expedition from 1893 to 96, he sails across the northwestern coast of Russia as far as the islands we see towards the right, and he allows the ship then to be frozen into the pack. The ship drifts north, but not as far north as he had hoped. And ultimately, he and a companion leave the ship and try and get to the North Pole on foot. Doesn't quite work, but they get pretty close. And then they have to make their way down to Franz Josef Land, which we see closer towards the middle of the image. They nevertheless become enormous heroes back in Norway and indeed around the world. Now, that didn't obscure the fact that the drift of the Fram had done two things. Firstly, it did show that a drifting platform could reveal useful oceanographic data along the way. It was a useful platform from which to take measurements, and it did develop knowledge of the currents and the basic facts of the chemistry of the ocean in the high Arctic, which otherwise would have been difficult to obtain. But I think we see here a dynamic that persists. The Fram became famous, the platform became well known, the exact work that platform did in the public mind, I think, became secondary to the fact of the ship having done an exceptional thing. So Nansen goes on, one could argue, to bigger and better things, possibly. He becomes a major figure on the Norwegian political scene, ends up becoming Norway's first minister in London after the country obtains independence in 1905, and goes on after the First World War to work for the League of Nations on refugees, in particular in Ukraine, and was credited with bringing in the so-called Nansen passport for stateless refugees. However, he's probably still today best remembered as a polar explorer. And the idea of the drift station that would reveal knowledge of the Arctic was picked up in the Soviet Union in the years between the world wars. Now, the context for Soviet interest was not reaching the North Pole, rather it was the Northern Sea Route, the bit of ocean immediately above the Soviet Union, stretching all the way from its northwest extremity near the border with Norway, or it was a border with Finland then, between the world wars, right the way across to Kamchatka and the Bering Straits. That route, like the Trans-Siberian Railroad, would be important for the Soviet Union for practical reasons. And drift stations that could acquire knowledge of ocean conditions in addition to meteorological data could have practical benefits in revealing something about the nature of that ocean, which was intended to be used as an active transport route. At the same time, I think it's fair to say, just as Nansen was a hero, in addition to being an oceanographer, in Soviet culture, particularly in the 1930s, Arctic exploration, Arctic aviation in particular, became a prominent element in government propaganda. And propaganda is perhaps selling it a little bit too short, because these really were individuals who commanded public attention, in addition to the data they provided being practically useful. Glavsev more put, the powerful state organisation that ran the Northern Sea Route also had responsibility for procuring knowledge about the area. So the first Arctic drift stations begin here, and they're not ships, as Nansen's Fram had been. They are large pieces of ice. And the idea is simple. If you get a piece of ice that's big enough and stable enough, you build quite a small rudimentary camp, can be reached perhaps by aircraft. The people who are based on that ice flow just follow it wherever it goes. It drifts and you record as it takes you. So, again, establishing these drift stations became an important element in Soviet public consciousness, and the individuals responsible for it did attain a measure of fame. Then the Second World War happens. And it's fair to say, I think, that in 1945, when the war ends and Stalin essentially closes the Soviet Union to the eyes of Western scientists, a perception continues in the West that the Soviets, they're probably still doing those drift stations, they're probably still studying sea ice and oceanography, and they've probably discovered a lot. They're probably ahead of us. The drift stations become part of a broader conception of the USSR as being ahead of the US in Arctic oceanography. Now, the US also is interested in obtaining information about the high Arctic. And initially, it's mostly done from the air. This image here from Popular Mechanics magazine, I think, and that nice map we have there, demonstrates the flights that were made by large, that's a B-29, same bomber that dropped the atomic bomb on Hiroshima, the largest bomber in the US fleet at the time, and also capable of long-range reconnaissance missions. The B-29s would fly towards the North Pole on a route similar to the one we see on the map there, and return collecting meteorological data along the way. Weather reconnaissance was the primary publicly disclosed function. At the same time, of course, there was something of an espionage element, seeing just what's happening in that remote high Arctic, and also scouting the stability of the pack ice with a view to potentially assessing could aircraft operate from high Arctic patches of ice. And that's a question that's going to stick in a lot of American military minds throughout the 1950s. Quite why you'd want to fly an aircraft on and off the ice? Partly it's, well, if you have a bomber that stops, can it take off again? Partly it's also, I think, it can expand the range of potential military operations across an area that is rapidly becoming viewed as a potential combat theatre, with the Cold War setting in with rapid pace. So in the second half of the 1940s, US interest primarily comes from the air. But if you think about it, simply by looking out the window of those reconnaissance aircraft, you sometimes see some things that could be potentially useful, and in this case, the largest and I think most famous of the floating ice islands was a product of these weather reconnaissance flights. The floating ice island T3, also known as Fletcher's Ice Island, after Joe Fletcher, the US Air Force official who had spotted the island and was largely responsible for ensuring it was put into service as a drift station. So T3 is discovered by the US. Well, discovered, I say discovered here, it was quite probably seen earlier, but it became conceptualized as a specific known object in 1952, and very quickly it becomes occupied. Now, the US military does see T3 immediately as being useful, excuse me, because it can be a little like the Soviets thought, a stable platform for researching currents and weather conditions. Now, there's another reason as well, which is that T3 could also be useful for taking acoustic measurements, and acoustic measurements were very important for both detecting submarines in addition to determining how ocean characteristics affected the ability of submarines themselves to detect the pack ice above them. So, the big question, who used T3 at the start? The first answer, I think, is oceanographers and geologists. who were interested in the Central Arctic Basin. T3 was discovered quite close to the North Pole, drifted quite slowly, and if you were an individual interested in the chemistry, the currents of the Central Arctic Basin, this was potentially a very useful place to study, or to base studies. At the same time, for some geologists, particularly those who were interested in determining, for instance, the density of particular areas of ocean crust, interested in gravity anomalies, potentially this could be a very useful research site as well. So there was legitimate interest, I'd say, particularly from oceanographers and geologists. Meteorologists as well. Not just learning about the meteorological conditions in the high Arctic for their own sake, but also potentially for improving weather forecasts further south, particularly with an eye to potential aircraft bases around the very high coasts of the North American continent, and indeed also the Thule Air Station in northwestern Greenland. Having a drift station which was stable enough, I mean, we see the houses there. T3 was pretty big, a few kilometres across. It wasn't going anywhere. You could land quite large aircraft. You could, in essence, build a village on there in quite a stable way. This permitted observations to be taken and small laboratories even to be built too. And finally, Navy personnel. This is where I start to come up against a couple of issues in the archival record. It is now, I think, well established that the US Floating Ice Island program, and T3 at the start in particular, was, as I mentioned, very useful for acoustic measurements that could both potentially help detect Soviet submarines operating under the Arctic Pack and help American submarines to navigate better. You knew the chemistry and the physics of the oceans, how sonar waves operated in cold, ice-covered waters. That could aid submarine navigation. Submarine navigation, in turn, starts to become important because the idea of submarine-launched nuclear missiles starts to be taken seriously by the Navy. And it's one person in particular, Waldo Lyon, who's based at the Navy Electronics Laboratory in San Diego, who really drives the idea of submarines under the Arctic pack ice as potentially important platforms for a US nuclear deterrent. As the 1950s continue, the Navy starts to really take this seriously. Lyon is not shy about pushing the importance of submarines, and he in turn is able, his interests then align, I think, with the Navy's. Now, whereas the oceanography, the geology and the meteorology is largely unclassified, that is not the case with a lot of the acoustic work. Consequently, it's not as visible in the open historical archival record. And it's something I've kept in mind too. As we get to this question of how useful was the infrastructure, if it was useful to people who couldn't publicly say it was useful, the issue can become somewhat, I think, for a historian, you can risk not getting a full view of the picture as it was at the time. There's a story told that when Lyon transited through the Arctic Research Laboratory at Point Barrow in Alaska, the Navy-operated small Navy-operated research station from which T3 was supplied, he literally had to hide sometimes so he wouldn't be seen by others passing through. That's perhaps a slightly extreme example, but I think it does point to an underlying fact. Naval research conducted from the floating ice islands, T3 I think being the best example, it happened, but it's not as historically visible as other things, and I do sometimes wonder how invisible was it also to other people, other researchers who found T3 useful and interesting. Nevertheless, if the Navy is interested in the data that can be procured from the floating ice islands, it goes a long way to answering the question, why did the Navy feel it was worth maintaining this infrastructure, which after all, it's not cheap to supply these by air. It's not easy when we work in Arctic conditions, and consequently, the bar has to be fairly high in terms of its utility. If the Navy has a classified reason, that bar can sometimes appear to be reached more easily than it actually, or rather it can give a misleading impression of how high that bar had to be, potentially. Now, having established some of the basic dynamics here, I think it's fair to say that as the 1950s go on, T3 proves to be quite useful. However, the Navy has now made significant investments. It's built T3 into an established facility, and the Arctic Research Laboratory, from which it is supplied, has also started to absorb a lot of the Navy's research funds. The Office of Naval Research, which will be familiar to many people here as the patron that in many people's telling really turned on the tap that provided money for all kinds of basic research related to earth sciences in this period, also funneled a lot of money to the ice islands and the Arctic Research Laboratory. But it's not true to say that that flow of money was unlimited. Because T3 existed, it had use to the Navy, and it already had all those buildings. There were already established supply patterns with aircraft flying from Port Barrow. It became easy for the Navy to just to recognise this as an established investment, and consequently researchers who could work on T3, they found it much easier to justify naval support for their work, not necessarily because it was more directly useful for naval aims, often it was, but because the infrastructure was already there. Similarly with the Arctic Research Laboratory at Point Barrow, if you had a research project that could be done from Port Barrow, the facilities were already there. You fit into an established scheme. Your research could be more easily accommodated. My argument here is that this comes with opportunity costs. Alongside the opportunities that T3 provided and the Arctic Research Laboratory provided, there were opportunities that were foregone. Now, it's difficult to tell a counterfactual history, exactly what was not done that could have been done, but I think even at the level of orienting the expectations of researchers towards the infrastructure that already exists, I think by the end of the 1950s, that dynamic is already there. The Navy would very much like to support projects that use T3 and which use the Arctic Research Laboratory. If you didn't, you had a higher bar to clear, not necessarily because of the nature of your actual research, but because of the difficulty that might be involved in making that research happen in practical terms. So, by the start of the 1960s, my contention is that we start to see a phenomenon of the tail wagging the dog. This is an expression that I actually have seen people use a couple of times in the archival record, and which broadly refers to the phenomenon of the existence of the infrastructure, in this case, shaping the research priorities, rather than the research priorities determining what infrastructure should be obtained, procured, and maintained. It starts from a very basic observation. If infrastructure for research exists, projects that are able to use it will inevitably be privileged. And I don't think that's a particularly controversial or indeed insightful thing to note. It is, however, important because of this issue of the opportunity cost that is raised. And this becomes particularly true when we think about the fact that T3 moves. It does drift. And as the 1950s progressed and the 1960s began, it started to drift into areas that, in particular, some geologists found to be less useful. And at one point, it actually runs aground north of Point Barrow, not too far north of Point Barrow. The platform itself, the advantage it had that it moves, you can track changes as it moves. It takes you to different areas without you actually having to do any of that moving yourself. That was great if it moved to places you liked. It was not great if it moved to places you didn't like. And there's nothing you could do about it. A further example of this came from ARLIS-2, another ice island that the US occupied, which initially was very useful. And then there comes a point when it's going to drift further south. And it looks like it might drift down the coast of East Greenland and melt away as it goes further south. And this would be really great. And there's some discussions. Could we maximise the value of this? I mean, we don't know much about the currents off East Greenland. This would be a really great thing. But it's a matter of probabilities. As it sits in the high Arctic, you can make an educated guess where it's going to go. You can't know for sure. And there's an element of holding your breath and waiting to jump. It does end up going down the coast of East Greenland. That is a very useful way for it to end its existence, but the platform, in essence, had the agency there. You did what the ice island permitted you to do. As I mentioned, for geologists, this could sometimes be difficult. Ned Ostenso, who was involved in some of those gravity determinations, at one point, I think in about 1962, he's involved in a project that involves taking measurements in the Central Arctic Basin. Oh, brilliant. He's got good connections. You can use the ice islands. None of them are in a useful place at the time when he wants to do this research. And you can't move the island. The island affords you possibilities for research, and the island can also deny those possibilities simply by virtue of its location. By contrast, the Arctic Research Laboratory at Point Barrow was lovely and fixed on land. You knew exactly where it was going to be. That could be an asset, but in turn, of course, if you had a project that didn't use the immediate environment or couldn't use facilities that were based there, when the Navy had already made such a substantial investment, it became difficult to think of research conducted away from the laboratory as potentially being as easy to support. I have seen a few records from around this time of individuals who wanted to pitch projects either in places like Ellesmere Island in the northeast of the Canadian Arctic archipelago, sometimes even on Greenland. And sometimes the responses would be, we think this is an interesting project. Don't you think you could run this out of Point Barrow instead? Trying to operate on the ice off Ward Hunt Island near Ellesmere Island. This is very interesting, but we've got other floating ice islands. The existence of the infrastructure, in essence, I don't want to say it determines what research can be done, what is funded, what is prioritised, but it does play a role. And there's an increasing sense of frustration that, as I said, the tail is wagging the dog and that the infrastructure no longer matches what the researchers actually want. The Office of Naval Research starts to notice this, and they start asking the researchers who have previously worked there and who they know work in the high Arctic. They say, look, can't you give us some better research programs to make use of this? And there's almost an element, partly irritation, partly frustration, and partly also pleading. We've got this nice infrastructure. Come on, just can't you find some programs that make use of it? And the role of the Office of Naval Research's Arctic Project Officer, a botanist named Max Britton, becomes in essence to try and drum up research that can justify the continuing work on the islands. The Navy starts to lose patience. It's difficult, it's expensive to supply places like T3, like ARLIS-2. If the researchers aren't particularly interested, Max Britton grumbles at one point, it'd be nice if they at least let me know and then we could just go and do something else. Now, I think he was just having a bad day and complaining because he couldn't just do something else. He couldn't wish the Arctic Research Laboratory to move. He couldn't wish T3 to not exist anymore. But the problem did persist. If oceanographers wanted to do things and to do research that didn't actually make the floating ice islands or indeed the Arctic Research Laboratory central, there was a problem. And that problem only got worse as the 1960s continued and the Navy starts to lose some of its interest in the high Arctic. Partly it's because experiments into things like landing bombers on the ice, I think they'd learned all they wanted to know. I don't want to say that things like sea ice research had reached a natural conclusion. They certainly hadn't. But some of the immediate practical issues, how do you land a large aircraft on the ice? What are the parameters? What do you need to know? I think the Air Force had gained quite a lot of knowledge and didn't feel a burning need to know more. Moreover, the idea that it was going to be bombers that conducted warfare across the high Arctic, that was in decline. From the early 1960s, it's to some extent submarine-based platforms and also intercontinental ballistic missiles that are going to be the primary delivery systems. It's not quite so strategically important in the near term to perhaps know some of those basic aspects of the dynamics of the Arctic environment. But the classified element is still there. I'm going to defer to a lovely book written by a historian called William Althoff, who has really, I think, gone into a lot of detail about the US and to some extent also the Soviet floating ice islands at this time. And he makes the point that some of the later ice islands towards the end of the 1960s operated on quite a different model. They were small, they were very easy to set up, correspondingly a little easier to abandon, and it was things like acoustics which really were central. And to that, in a sense, the question of making the researchers interesting in the island has been avoided. If the cost of setting it up is less, if the infrastructure has less inertia, there's less of it. It's less of a cost if you want to just abandon it. You can afford to set things up to solve shorter term problems of immediate need, capitalise on a large piece of ice that happens to be floating in a useful area at a useful time. And if it's the acoustics, if it's the Navy operations specific research, rather than basic research into things like oceanography and geology that is central, the bar that the Navy has to reach to justify setting it up, that's a bit lower. The Navy can, in essence, do things it finds immediately useful without having to engage with a wider scientific community. The floating ice islands, T3 does continue through to, I think, the early 1980s. I'm having a blank on exactly the year it ends. T3 does continue for some time. By the end, I think it's fair to say it was still a useful research platform for many, but I think it's also true to say that a lot of working oceanographers were already thinking about platforms that they could control better. Going back to the Fram idea, a large, stable barge that you could freeze into the ice. A lot of people already in the mid-1960s thought this could be better because if it finds itself in a place that's not so useful, we just move it. So, ice islands, I would like to argue here, there is a rise and a fall to this story, at least seen from the perspective of how useful they were to researchers working in the non-classified domain. I'm not quite sure how well that maps onto the classified domain, but I do think that element is there. So, then, now I'd like to try and get towards some broader questions, as promised or threatened at the start. I think there are some very clear parallels, particularly with how oceanography works in the polar regions in the present. The ship we see on the left here is the Orden, the icebreaker operated by Sweden, which is, I think it's fair to say, the pride and joy of the Swedish polar research effort in many ways. Now, Sweden has quite a wide portfolio of research in both the Arctic and the Antarctic. It's got some excellent researchers working in terrestrial as well as marine questions. Nevertheless, the Orden occupies a central place in the way Sweden thinks about polar research. It's partly practical. There are a lot of very good oceanographers, and for them, having an excellent large icebreaker capable of housing researchers, allowing them to do their work, that's a very good thing. It also does, however, I think, reinforce a sense of inertia. If you know there's an excellent icebreaker, it's going to be there next year, the year after that too, it becomes, I think, easier to plan a long-term research program in oceanography. Similarly, the Orden is now reaching the end of its lifespan. There have been some discussions in Sweden about its replacement. And again, I think we see a sense of infrastructural inertia here. The question is not, should we replace the icebreaker with something else? No, there's going to be another icebreaker. Partly there's good practical reasons for this. The Orden can also do things like break the ice in the Gulf of Bothnia between northern Sweden and northern Finland, in addition to assisting polar research. But it's also got a symbolic value. The Orden is the most visible and recognisable piece of Swedish polar research infrastructure, and as such, it does, I think, help orient the interests of the Swedish research infrastructure towards oceanography rather than terrestrial research necessarily. I don't want to make the argument this makes terrestrial research impossible to fund, far from it. As I said, there is ongoing very good terrestrial research in Sweden. But I don't think it's possible to avoid the conclusion it does shape the research funding environment and also the expectations of both researchers and those who support them. Norway similarly has a large terrestrial station in Antarctica at a place called Troll. It's Norway, of course. There's a large expansion underway, the Troll Observing Array, which people will say quite openly, it's going to be big enough that it's difficult to see how Norwegian researchers alone could make use of it. But if you've got a large piece of research infrastructure, the Norwegian state put up the money. It's there. Good, stable conditions for long-term partnerships. How can that not help orient the interests of researchers towards the infrastructure that is present? If you've got a question that could be answered by using the facilities at Troll, it's very easy to see how that becomes possible in a way that might not be if you had to conjure up the infrastructure from scratch to make it happen. Similarly, I think we can also think about satellites. And here I'm getting into, I think, slightly murkier water. Not in the sense that a satellite is a directly analogous piece of fixed infrastructure like an icebreaker, a land-based station, or even a drift station, but in the sense that a satellite is a large investment. If the satellite blows up on the launch pad, your investment is gone. Consequently, there's a lot that is invested not only in financial terms, but I think also in terms of people's careers. If you decide to take that gamble, high risk, high reward. If you have something that you'd like to do doesn't quite fit with that satellite, it's not like you can just say, well, we'll have another satellite, thank you. There's a push and a pull here. Now, of course, there's going to be a dynamic that leads to that satellite being useful in as many ways as possible. But satellites cannot be turned to help absolutely every project. A satellite that is particularly useful for determining the density of sea ice, for determining ocean temperature, for instance, can give you a lot of very good data. But at the same time, you are to some extent restricted by what that particular satellite can see, what it can tell you. The piece of infrastructure is not incidental when it comes to the research that can be conducted. And similarly, because it's such a large investment, there is going to be some element of, if your research is tied up with that satellite, in some ways the possibility the satellite affords are going to determine what kind of research can be supported and what gets priority. Again, I don't think this is a very methodologically groundbreaking point, but I think it does get... I mention the satellites because I would like to just try and tease out exactly how far the infrastructural inertia that I see very clearly in polar research with the drift stations and to some extent with terrestrial stations too, can also be applied elsewhere. So, I'm going to get to my conclusions. The first one, specific to the floating ice islands, they created opportunities for oceanographic research, but on an opportunistic basis. You took what the floating drift station could give you. Now, of course, the T3 was established in the first place because the US Air Force and the US Navy knew it could give them things that it wanted. meteorological data, oceanographic data, an acoustic platform. As the drift station moved, as T3 shifted its own location, the possibilities it afforded shifted too. And those had to be reckoned with. Secondly, the existence of the infrastructure itself created a demand for research. And at the non-classified level, I think this results in things such as Max Britton's complaint about the lack of good research programs he found to fill places like T3. Infrastructure was there. Surely oceanographers could come up with research to make use of it. And in turn, if he's backed by Office of Naval Research money, you've got a project that can use that infrastructure. You see how the pieces fit together. But there is this wrinkle here. As Lionel mentioned, we worked with Simone Tolchetti on the Earth Under Surveillance. And one thing that I started to think about a lot more seriously then, and the older I get, the more I realise I think Simone was right about this. Classified research does fill a larger part of the research universe, certainly in certain areas during the Cold War, than I had realised, and I think this is one of them. It's easy for me to assess Max Britton's complaint, come on, give me good research programs, I need to fill T3. But at the same time, if I as a historian am having more difficulty in figuring out, but exactly how big was the classified research that was done there? How much did it fill? And also, it may not have filled very much, but was it so important that that in itself could provide justification? How does that shape the way that I interpret the non-classified research that was done there and the dynamics of the match between the available infrastructure and the inclinations of researchers? Because if that classified research was so important that you wanted to keep T3 going, but you didn't want to give the impression that, well, we're doing it just for the secret stuff, well, of course, you very aggressively try and get researchers to come in and use it. I'm still wrestling with that, to be honest. I recognise it's a problem. I feel I can determine its contours. I feel I'm a long way from giving a satisfactory answer as to exactly how seriously that dynamic of we must get the non-classified researchers in. I don't want to say that was performative. I think it was a real issue. And the Office of Naval Research really did want to see its infrastructure used. But the exact importance of the research demand in terms of justifying the infrastructure, that's one that I find a little bit harder to reckon with. And then finally, the question of inertia, which I increasingly think is an underestimated factor in the history of science. This goes back to the opportunity cost issue. If you've got a floating ice island there already, you can't just find another one. T3 was a uniquely big and beautiful ice island. I mean, it was remarkably large and stable. You used the opportunity that you found there. RLS-2 was smaller, less useful in some ways in terms of being a large base, but firstly, it had some very useful, it looked like there were some rocks on it. It clearly had taken with it a little bit of the surrounding terrain when it carved off. That was more interesting to people, and also it ended up floating down the East Greenland coast and meeting its end in a very, very useful part of the ocean. Now, because those islands were already there, the investments had already been made in setting them up. And I think this goes also to the Arctic Research Laboratory at Point Barrow. Because they were there, they in themselves created a demand that needed to be filled. Max Britton's complaint was real. The Navy had facilities, it wanted to see them used. And if you had projects that made use of them, the Navy would look more kindly upon that than the Navy giving you more facilities, different facilities to enable you to do different research. Ultimately, the Arctic Research Laboratory is closed in 1980, and that's in part because it just keeps growing. Incrementally, it gets bigger and bigger. And eventually, a new Chief of Naval Research comes in the early 1970s who looks at what he thinks is a grossly overgrown research facility, which is looking at things such as the physiology of wolves. Things, and he scratches his head and he says, don't see what this has got to do with naval priorities. How on earth did this come to happen? And part of the answer is, I think, inertia. It was there, and so it grew. And as long as one knew that there was this facility there, it housed projects. If you had a project that made use of it, you were going to be looked on favourably. That cycle reinforced itself. Not only did that shape the nature of Arctic research to some extent, the kinds of questions that could be asked, where did you have the infrastructure to allow you to answer them? I think also that inertia leads to the continuation of that infrastructure's existence, and it often becomes harder for that infrastructure to then be changed or to go away. Ultimately, the Navy said, look, we're not paying for all this anymore, particularly as the strategic context changed. But the bigger the Arctic Research Laboratory is, the harder that decision it is to take. So inertia as a factor in the history of science, I do think, again, I feel like I've made a whole bunch of very obvious points today, and this is perhaps the most obvious of them all. If something is there already, of course it's going to be easier for something to be built upon it and for that thing to be used rather than a thing to be brought into being. And the effects of that dynamic upon research questions and issues of opportunity cost, I think, need to be fleshed out a little bit further. I'm going to say as a coder here, my last words here are going to be the framework of big science. I have thought about this and I'm very open to comments how useful we think it is. I'm a little hesitant because I think in essence this is small science that sort of grows incrementally into larger science along the way. Yes, it's big science in the sense that it costs money to set up a thing like the station on T3, the Arctic Research Laboratory. I'm not sure it's big science in the sense that that resources and networks need to be created in order to bring a thing into being. I think to some extent the fact that that thing already has been brought into being does some of the work. But again, that's a dynamic I'd like to think through. All right, I've talked for long enough, so thank you very much to everyone, and I look forward to hearing if you've got any questions.
Thanks a lot. Sorry. Thanks a lot, Peter. This was great. And our group, as you know, it's devoted to Mediterranean history. There are surprising parallels between Mediterranean history and polar history. I mean, the differences are obvious. And since we have the pleasure to have you here in person, if you look at the windows in plain winter, you will see the obvious difference between, a place close to the Mediterranean and the poles. But what is interesting is that another maybe obvious difference is that the Mediterranean is geopolitically packed, and it has been so for many, many centuries and even millennia. And we still think of the poles as, empty. But I think what is interesting is in your research is that it has also become, in the last maybe 100 years, geopolitically packed and divided, and there are borders and there is sovereignty issues and so on. And I think accessing them through science as you do, it's also revealing for some of the processes that have been going on in the Mediterranean region in the last 100 years as well. So that connection is very interesting. Thank you very much for that. And if there are questions, comments, for people online as well, of course, not only in the room, go ahead.
Got a bunch of questions. Just want to start with maybe is you gave quite some caveats about you as an historian not really being able to figure out how much of this research was classified, how important that was, and how much of the legitimacy of the whole research infrastructure came from that. I'm wondering, wasn't that a problem for the people at that time? Were there so many people involved that there was this active creation of not knowing what was going on and just assuming that other people would make more use of it, so that kind of everybody had a reason to assume it was useful anyway to have that infrastructure, even though there might not have been?
Yes, that question of how much do people recognise these dynamics at the time, you would have had to be willfully blind to be working at the Arctic Research Laboratory sometimes and not realise there were big things going on. About 1952, there's a thing called Operation Ski Jump, which is largely figuring out how much can we, is it the practicalities, landing aircraft on the ice, taking them off. And of course, there's a whole lot of personnel who turn up. But there are some individuals there who are doing non-classified research, and they're very much put into the limelight. There is also, along that, someone comes up with a bright idea of bringing carrier pigeons to see if they also can do their thing in the Arctic. I mean, this 1952, carrier pigeons, I'm not joking. Doesn't work, and I have seen a rather sour letter saying, yeah, it didn't work, and the guy who was running it went home, and we ended up having them in a pie. So, yes, so much for that. So the idea that there were things happening that you saw they were happening, you were aware of it, but two things. Firstly, you don't entirely know the dimensions of that world. And I think when Ron Dole talks about science in black, I think it's very important, his work. There is an unknown universe to some extent, and even if you can see the outlines, you never quite can divine either, firstly, exactly what the scope is, and secondly, I think, if I can use another metaphor, the density. And if the scope is the size, how many people, how much money flows in, by density I mean even if it's small, even if it only has 3 people, if that's a really important thing, it may not be as obvious that's an important thing, but if the Navy thinks, yeah, it's actually worth keeping the whole station running so those 3 people can do their thing, that is not a thing that necessarily would have been obvious to observers at the time. And for me as a historian, it makes me realise I should be very careful about using volume of people and sometimes even volume of money as a proxy for importance and significance in terms of how much that research aided either the Navy as an institution or the Office of Naval Research in terms of determining whether that piece of infrastructure should be prioritised. There's another obvious answer here, which is why don't I do the work, go to the National Archives in Maryland and dig these things out? It's actually, okay, I'm going to be rude here. I don't actually enjoy working with the National Archives and Research Administration. I don't always find it the easiest place to work and for things to be obtained. And I think this is also where we have another dynamic, which is if researchers like working in particular archives and dislike working in others, they can potentially become prone to telling stories that reflect one thing and not another thing. And that's the thing I'm also very aware of myself. Again, it's not rocket science to state that, but it is a thing I keep in mind.
Well, I mean, just a minor thing on that. I don't know why you have such a prejudice against NARA. If they organize the diplomatic histories, how's it called? Oh my God, the American Foreign Relations Conference every 2 years. You can attend to that and then go to the archives. You may not find anything. That's a different issue. But come on, it's a great place. Anyway, Sam has a question.
Sorry, because we're on YouTube and this is official, I will say for the record, the staff at NARA have always been very kind, and it is a place that does. It is a place that does work. My prejudice comes instead from the fact that the first time I went there, I ended up getting sufficiently sick I had to get wheeled away and taken to hospital, and I think that's probably coloured my perception of it unfairly ever since.
Sam, go ahead.
Don't panic about surveillance and YouTube. But I would say, just on class, which is not what I want to come in on, but on classification, it's good to remember that as soon as submarines become involved, these things do become harder to track through archives. In the case of the UK, if you put in a Freedom of Information request, you'll get the response that the British government has not commented on submarine operations since 1906. That's the end of it, and you can't look. But what I wanted to pick up on is I think you make a really good point, Peder, about the idea of research infrastructure as a geopolitical tool, especially when you start talking about the present. I don't think you really articulated that in the past quite so much. I think you just took it as assumed. And that's where I think the solid parallel between, I would say, the whole ocean, but if we'll just stick with polar versus Mediterranean comes in, this concept of if you build a research platform which other people can use or your own scientists can use from many agencies, you can increase your presence through science, and science is for peace, and therefore it's more difficult for other navies to say, oi, you're in my space, because this is science and science is good, and it's difficult to code it differently. The thing that I'd like to pick you up on, though, and ask you is my question is, you kept saying if you want to do science, you go to T3 and you do science. Who couldn't go to do this science? Who is excluded in this story rather than who is included?
Thank you. The very obvious one is women. Women were systematically excluded from anything to do with US Navy Arctic research in the 1950s. And this included also the Arctic Research Laboratory to some extent. Bryna Kessel, who was, I think she was an ornithologist, she's mostly infamous these days for her role in Edward Teller's Project Chariot, this planned idea to use nuclear explosions to create a deep water harbour for no readily obvious purpose in Alaska. And she was the point person between Edward Teller and the University of Alaska to do research related to that. But she had her own research, and at one point she's almost got to the point where she's about to go into the field in Umiat, which is a satellite camp from the Arctic Research Laboratory, and someone figures out that the B in B Kessel stands for Bryna and not for Brian or Bob, and suddenly there's this panic. No, well, she can't go. We hadn't realised she's a woman. What? And I think at one point someone actually writes an official memorandum saying, well, she can't go. Umiat is no place for a woman. So if that was on a terrestrial camp, the idea of women going to T3, I think, was really not going to happen. As far as I know, there is one woman who goes to ALICE 2. It's an Icelandic journalist who is flown in to write a nice, happy story. So women are excluded. People who can't get us... I want to be very careful when I say people who can't get a security clearance. You did need to get naval authorization. I don't think that's quite the same as you needed to be security cleared to go into a sensitive area, as much as the Navy had to be convinced that what you were doing was sufficiently, that not just what you were doing, who you were, passed the bar that allowed the Navy to take you on. If you weren't a US citizen, wasn't impossible, was harder. On the other hand, if the Navy knew you and you were already within that world, and I mean, I don't mean were you a naval officer, but as in were you a researcher who had a relationship with the Navy, then that definitely smoothed your path. And that does perpetuate, I think the inertia does also extend to insiders and outsiders in research networks. If you've gone to the Arctic Research, bugger, I said it again, I'm sorry. If an individual has gone to the Arctic Research Laboratory every summer for 15 years to see what the lemmings are doing, they will have a stable relationship not only with the logistical aspect, but also the Navy. Oh, just sign off, we'll do it again this year. If you're going for the first time, it's a lot clumsier, it's a lot more awkward. Those relationships have to be built. So I think there's an inertia there as well. Were you thinking more in terms about people who the Navy thought were undesirable, or?
I was thinking that. I was also covered most of what I was thinking of, but it's more that some of these floating platforms and some of the ones you mentioned for the more recent are very keen on showing international collaboration. And I just wanted to be clear that that's not what's going on here. This isn't about creating NATO in the Arctic. This is American presence. And even in your story, Canada seemed to be very distant in terms of being welcome, but not necessarily geopolitically or geographically distant. So I was just trying to clarify that this wasn't some kind of Western project. This is very much a US project.
I think that's a good point. Two things I'd add there. Firstly, one of the things that gives me reason to believe that the submarines and the acoustics were more important than I've realised is that Canada, I wouldn't say they're not bothered by the floating ice islands, but they're not a thing that they see as particularly important to them. And again, I think there's an obvious reason. Canada does not have a submarine-based nuclear deterrent or any plans to do so. And consequently, the floating ice islands, they lack that central justification that I think the US gives them. Secondly, they are a site, I think you're right, they're not Western, they are very much US, but at the same time, there is this lingering idea that possibly they're a site where something can be done with the USSR. And this seems crazy on the surface, particularly as the Americans are very keen on trying to figure out what the Soviet stations are doing. At one point, they identify an abandoned one and literally a parachute drop in two people to do a survey of the abandoned station, try and assess how much acoustic equipment have they got? What sort of things are they trying to do here? Did they leave any written records we can souvenir? Very much at that intelligence gathering level. But at the same time, there's also a sense that if some Soviets came and sat on our station and we had a very, very well publicised meeting, that could have some geopolitical value too. You'll be very unsurprised to learn that that idea is pushed by a number of scientists, and as far as I can determine, it gets no traction whatsoever with the Navy.
Is it on?
Yeah.
Thank you. This was really, really illuminating. I think it helped me understand your chapter a lot more, probably just because it was the fourth of some more. So I also have I think I'll just limit it to 2 questions probably. The first is a clarification, because I think I'm missing a step. So you say that they see the islands and they find potential in the islands and they build the infrastructure. But was there no assessment before building? Do they not actually, is it immediate, or this looks potential? Is there some form of assessment before they start the actual construction? And the second, I know this is not the focus of your research, but I'm wondering, what does the element of the floating island say about the agency of more than human objects in the history of science? Can this help to sustain the argument that they have agency? Or I don't know what your take is on this, but I thought it could be very useful to add to the literature in that sense.
Thank you. That's 2 really interesting questions. The first one about the assessment, surprisingly little. It is very opportunistic. At the start with T3, because it's the first big one, I think, well, firstly, can we land an aircraft? And they see, this is huge. Yeah, we're probably going to be okay here. And by the time they get to ARLIS 2, which is a lot smaller, I think it's the gap between when it's spotted and when a camp's set up. It's something. You watching on YouTube, someone will know this, and please don't judge me too harshly. It's a very short gap. It's only about a month or so. So by the end, it's, I think that's, if it looks like this, we can probably do that. And T3, simply by virtue of its size, I think it negates a lot of the need for assessment, because they think, my God, it's so big, we'll be able to get away with that. The question about agency, I am probably too old-fashioned about this. I am still fundamentally a little bit unsure of the ice island having agency, but it has got something. And I don't think the term agency is necessarily, I don't think it's inappropriate here, because it does frame what people can do. I used the term affordance a couple of times, like what opportunities it affords, and I'm influenced there by the work of archaeologists, in particular people like Ian Hodder and his work Entangled, which again, many people on YouTube will be familiar with it more than I. And Hodder's idea that the material object doesn't necessarily determine what a person can do, but it affords them certain possibilities. So in other words, it does play a role. You can't just make that thing exactly what you want. If you've got a piece of stone, well, maybe you can make a hand axe out of it, but you can't make whatever hand axe you want. The stone affords you certain possibilities in that sense. And I think the ice island is quite similar. It lets you do some things. It doesn't let you do other things. The agency might be, I don't really like agency, but again, I'm far too old-fashioned about this. I still find it hard to think about agency without intentionality, and I know I'm a generation behind the times with that. But it does move. And the possibilities it affords the researchers do change. And if the term agency is involved to signify the active role of the ice island in shifting those frames, shifting what possibilities are afforded, then I think it can work. I think there's a very fair argument that I'm too hung up on being scared of the word agency, and I could just use it and it would make a lot of sense here.
I have a question. You are surely familiar with the work of Edward Jones Impotech. in his book, The Unreliable Nation, Hostile Nature and Technological Failure in the Cold War, he talks a lot about Arctic, probably a bit southern of where you are, but I don't know, Arctic infrastructure for research, in particular on ionograms and so on. And I think the idea of these infrastructures failing, or at least being very hard to operate successfully, provided some kind of cultural import to the research being conducted there. I don't know if there is a link to your story at all, because it's very different in some ways, but geographically similar, and the focus on infrastructure and this heroic culture of science in the poles are commonalities. So I don't know if what is your relation to that work?
Yeah, I do really like that book. And one of the reasons I admire it is because of the level of detail he goes into. And I think I'm guilty of focusing a little bit too much on the big picture. Why was there that infrastructure? Why was there that research program, rather than, but how did the research program actually go? And in essence, the role of the research program's success or failure as a factor in whether it was continued or not. I tend to black box the contents of the research a little too quickly, I'll admit. In terms of things going wrong, however, I have noticed, my sense is it's not so much at the level of did the individual instruments fail or did they succeed. But then again, I've been a little quick to leave that black boxed. I have looked a little bit more at the extent to which the logistics, the failure or the success of the logistics shape the research programs. And in particular, seismic work involved dynamite. And there's at least one example, a tragic example of someone who was very severely injured. In an accident. I don't think about this enough. When you work on Antarctica, even today, there's a term, the A factor, which is invoked in a very general sense. And that maybe agency does work here. The A could stand for agency. The A factor signifies that you can have the best laid plans, you can really have thought it out, you got your planning exactly down, and it still kind of went wrong because Antarctica just intervened, in a sense. And I guess I've also been a little bit too quick to say, well, it did things like, well, Ostenso, he wasn't able to do the work he planned. Well, it moved. I mean, what could you do? He couldn't control that. And to see those environmentally determined variables in the Arctic as playing a disproportionate role. Again, I'd be very curious to know, because things can go wrong in the Mediterranean too. Just because it's warmer and you don't have such horrible weather necessarily, doesn't mean it's a stable, predictable environment. And in turn, there are environmental factors that shape, that afford you possibilities to do or to not do research as well. I do start to think in my old age that we are sometimes, and when I say we here, people like me who primarily think about the polar regions, we are a little bit too quick sometimes to focus on the environmental factors, and the A factor, I think, is a classic example of that, and to foreground them in our analyses when environmental factors actually shape the possibilities afforded by research infrastructure everywhere. And just because I think, well, the Mediterranean is nice, I can walk around in a t-shirt, there's no polar bears, oh, come on, it's easy. That's not the case. You still have to deal with a particular environment. You still have to know that environment to work within the possibilities it gives you, and to deal with the fact sometimes the environment will not cooperate. And I wonder, possibly because the Arctic environment is exoticized in many minds, and quite possibly I suffer from that too, those environmental factors take on outside weight, and in turn they impede me from looking at the human factors, that influence the success or failure of a program, and too quickly invoking the A factor and saying, well, it's probably the environment that made it impossible for them to do what they wanted. Submarines, that might work as well. I mean, if you have a program on a submarine and it just didn't work, To what extent can you say, well, submarines, they're new and unstable research platforms. It was a problem with that rather than didn't think the research question through properly. And I wonder if the infrastructure plays a role in that form of historical thinking too. Sorry.
Wonderful, thanks.
Yeah, I had a question, but now I also want to ask something that follows up. So I'm kind of figuring out how to ask both at the same time. So I think that argument that you're making, the wider argument, which you keep saying is not that interesting, is actually very interesting in infrastructure or has a big impact on what kind of research is actually funded. And one of the terms that I think you didn't mention at all is a bias, is a research bias. I think very the context here you're talking about here, but not the Arctic, not only as an environment, but also as a place where secrecy plays such a huge role. So one of the key elements in your talk is that we don't really know what the military wants, what they fund, and so on. So that also has a huge impact on what kind of research people try to propose, right? How does that compound the whole story of infrastructure itself already? I mean, people take less risks, right, if they don't know what the military wants, probably. So even more inertia, or?
That's true. And I think, to take the second point first, certainly when I was trained in history of science, there was, I think, a strong sense that the Office of Naval Research was just this great benevolent patron that sprayed money almost indiscriminately and limitlessly across the earth and environmental sciences after 1946. And that view is now being challenged. There's been some very good research that has shown not only naval imperatives played a much bigger role than I think was previously thought, and also that there was a stronger level of orientation between funder and researcher. And Naomi Oreskes' work, I think, has been really important in this regard. And I think that's perhaps a bridge to your first question as well. I tend to avoid the term bias because I find it a little bit too pejorative, but I could see how it could certainly be used. I prefer, again, Oreskes' term mutual orientation. I find that quite useful, partly because it lets me get out of, I mean, you could say it's a cop-out too. If you know that a funder wants a particular thing and it aligns, then I think mutual orientation, I think, describes that dynamic. Bias for me determines almost that your work was deformed in a way. And I think we're getting a little bit back into that. To what extent was the history of science deformed, or what's the word that Foreman uses? Distorted. Yeah, that there was a distortion, that there was a path and the military sort of grabbed it and hauled it in a different path. And I know, obviously, I mean, Foreman's argument is a lot more nuanced than that. And the work, I mean, again, the historiography has developed over the last 30, 40 years. But I still think orientation allows for an openness of that path to be preserved. There was no path, but you had a funder, you had a researcher, and the way those two interact determine what path is taken. Rather than there is a path, the funder says, okay, researcher, you like that path, but actually I want you to do something else. And the funder hauls you off that path. And I think the term bias can have some connotations that such is the case, and I want to try and avoid that a little bit. Now, once the funder has started throwing money in, the researcher has started doing the work, then I think that path is there. And I think I'm a little bit careful about talking about path dependency, but I can see why it could be valid in that particular case. I like talking about inertia a little bit more because it's just once the thing's there, stopping it and starting again becomes harder than just keep going. And I think inertia captures that. Path dependency, I think, can convey a sense, but you couldn't do otherwise. I mean, you could. The Navy can abandon the ice islands, write off its investment, can write off the Arctic Research Laboratory. It's a big deal. And you have to think very hard and very carefully and think about the researchers who have oriented their research to that fixed infrastructure without the path dependency model, which I think can lead to a sense that there was nothing else they could have done. But there was other things they could do, just harder.
Yes. Ada has another question.
Yeah, again, this is mostly a clarification again, and I think the answer to this might be quite obvious, but we're using the term infrastructure like in a sort of general absolute sense quite loosely. And I wonder to what extent can this argument, the infrastructure leads the research, be extended to infrastructure in general, or is it limited to, research infrastructure? Because, I mean, again, that is very specific within the wider literature on infrastructure. It's a very specific categorization that I think can be useful. But I don't know if you think it can be extended to infrastructure as well.
Yes, and again, I plead guilty to being a little bit unnuanced in the way I use the term infrastructure. I'm sometimes a bit too quick to use it as a shorthand for stuff. Material objects that are provided in order for a thing to happen. And once those material objects are brought into being and are ordered in a particular way, they offer certain affordances for what can be done. And reordering them or bringing in new ones then has costs, as opposed to just using the ones you've already got. I think very much in material terms there as well, but they're not all research infrastructures. I mean, those military aircraft, they're not built for research. That's not why the Air Force got them. And so infrastructure more broadly, but then again, is an aircraft always a piece of infrastructure? Can the term be evacuated of meaning by being used too broadly? That's something I'm going to have to think about more clearly going forward, I think. Then there's also the element of the non-material. So yes, you may have the Navy providing all this stuff and these things and arranging them in a particular way that allow you to do particular sets of research. But there's also non-material things at play here too, such as expectations and careers. If you're Waldo Lyon, I have absolutely no doubt he genuinely thought he was working in the interests of the US Cold War state by arguing for investment in sub-Arctic pack ice submarine capability. He also sank his career into it. If those submarines get written off by the Navy, again, I don't think it's just rank cynicism to say then his career suffers as well, and that there is an inertia to that as well. I mean, I think that's an almost caricatured example, but I wonder how much that dynamic plays out in other ways too. But I know there's this big literature on infrastructure. I'm going to have to sink into it, and I haven't yet. So,
Sam, go ahead, please.
I was just going to say, the aircraft is a tool or a platform, but it's not an infrastructure. The infrastructure is everything around that makes that aircraft able to operate in that environment. So everything is not an infrastructure. You just got to be a bit more careful. There's a lot going on. I mean, one of the things that all of us who work on Cold War science and technology have built up over years from Paul Foreman onwards is the idea that a lot of this science was what makes this military is not necessarily that it's got military utility. It's science that could not be undertaken without military amounts of money and resource. And it relies on an awful lot of World War II army surplus being very cheap. So even when you're talking about explosives, Peder, it's because explosives are abundant and need to be used for something after the Second World War. The other acoustic research that's going on in oceanography in the 50s is using depth charges that have been used against submarines in order to improve the ability of submarines to avoid detection under the banner of doing the science of seawater and currents and things like that. And so I'm not going to say it's more complicated than it looks, but it is more complicated, and it's more about structures. The structure is more important in the infrastructure term. Sorry, just wanted to point that out.
That's an excellent point, and I think I'll simply nod my head and say yes to everything you've said. But also, you've also mentioned another thing I think is very important, which is the extent to which, I mean, you mentioned this directly, the Second World War and the creation of surplus military equipment. There's C-47 aircraft are just everywhere. And they are these wonderful rugged things that can do things like land on stable planet. had before. That's for sure, because of the war and wartime production. I don't know if the term inertia is correct there, because the war has finished, the production has stopped. It's just a matter of dealing with the stuff that was produced by the war. But it does, I think, afford a certain set of possibilities, because you can get those aircraft, you can get those huts, and consequently, the equation, is it worth doing this thing? That probably does shift it a little bit. Yeah, the role of the Second World War in this, that's something I hadn't systemically considered. I'm going to have to take that more seriously. Thank you.
All right, there are two more questions in the room.
Thank you for your talk. I've got a very brief question about something you said in the beginning. So the first research that was carried on regarding floating islands in the late 19th century, you said that the hope was put into it because they thought it could reveal something interesting about in the current dynamics and so on. So how did that sense evolve? What did they expect to find regarding current dynamics in the late 19th century? What did they actually find when they could deploy that infrastructure in the second half of the 20th century? What impact does this research on floating islands have on the sense of Arctic, in Arctic oceanography in general, but in physical oceanography in particular? I have a lot of thoughts on this, but I just want to put it this way, and then if you answer and open my mind, I will ask you again.
I'm not sure I can give a very enlightening answer. I'm not sure my answer will be so enlightening, I'm sorry. But at the start, possibly I'm too defensive about this. I do still think that despite the overwhelming military interest in Arctic oceanography in the 50s, I think there is still a genuine sense that this is an area civilian oceanographers don't know much about. And that basic curiosity element, I think, persists. And in terms of how it begins, there is an expedition, there's an American expedition to the Arctic, and the boat sinks, most of them die, it's awful. The Jeanette is the name of the ship. And again, I'm going to get in trouble saying this. It sinks towards the eastern end of the Arctic, as seen from a Russian perspective, and then bits of timber turn up on a shore a long way away, much further to the west. I think that's it. God, I'm struggling to remember exactly the dynamics. I think that's how it worked. But anyway, these pieces of timber from the ship become a proxy for how the currents across the central Arctic Ocean worked. And no one knows exactly how Arctic currents work at that time. It's just literally terra incognita, mare incognita. And so Nansen's idea is, how do you get to a place you otherwise can't go with a research platform, the ship, in that sense? And I think that fundamental logic persists through the 1950s, in that the drift station, whether it be a ship or an ice island, allows you to make measurements from a place you otherwise couldn't get to. And until you've got submarines and later on satellites, I do think that remains true. In terms of the continuity of those questions, I do think there is some continuity, fleshing out how the currents work. But again, by the 60s, I think that things like questions that weren't on Nansen's radar, he didn't think about gravity measurements of the crust and things like that. They are starting to come on the radar. And so the range of things you can do, but I think the underlying thought is still quite similar. If you want to get an observation from that place, you've got to get to that place. And this provides you the platform that lets you do that, in that sense.
I have more or less two questions in one, I think, or I'm not sure whether they are independent. Wanted to know how much do you think, or to what extent, the decisions to use smaller and more transient infrastructures for research were due to perceptions about the increasing uselessness of these larger stations. And that's interesting to me because want to avoid terms like bias, path dependency, or locking or something like that. But in the end, you're spelling trouble with your account, which I mean, you made your point, but it's spelling trouble. But for these ideas of science as a self-correcting enterprise, where anything can be learned from and changed, according to evidence and so forth. For content matters may be right, but not for many other aspects of the science. That's what you are suggesting. But this, if it were right that they learned from their failures or the increasing usefulness of the infrastructure, that will also mean, there's some element of rationality in the but it could be due also to military needs, not scientific ones. So I wanted to know your...
Yeah. Okay, at the risk of sounding neoliberal, it's amazing how much shortage of money causes people to suddenly become a lot more careful about their plans. And to that extent, I do think that the shift towards the smaller, more mobile structures, and again, Althoff's book on the Arctic floating ice stations in the Cold War, I think it really is very good and does take this up well. That shift is to some extent driven by the fact there's not enough money going around, and so you do things smaller and cheaper, which is kind of what the Soviets have always been doing. I mean, their stations are really very rudimentary compared to a big thing like T3, which almost looks like an Antarctic research station on a piece of Arctic ice. It looks terrestrial in the scale to some extent, I think. In terms of the self-correcting nature, self-correcting, yes, in the sense that when a piece of infrastructure no longer has utility, it is not condemned to remain in existence inevitably. And again, this gets back to the path dependency versus inertia point. If no one's interested, if it's moved to a bad place, if it's gone, then you can abandon it and move. And I think, yes, there is that element there. At the same time, self-correcting in the sense of the actual research agendas, well, again, this is horribly old-fashioned. I mean, I do think this is a Kuhnian paradigm in a sense. People are invested in a particular thing. And once you've become invested in, I use the ice islands for research, there is a sense that, well, it's a trajectory I've begun. The difference, however, I think there is that your research question could continue to be just as good and just as interesting. It's just the ice island can't help you answer it anymore. Like you have this program on determining on gravity measurements, but the ice island's in the wrong place. You don't want gravity measurements there. You want them from somewhere else, but you can't get to that other place because the island's not there. And that doesn't, I think, change the content of the research as much as it draws into doubt the match between the infrastructure and the question. Possibly, I think you can argue then, does this lead more towards a more nimble infrastructure model? Possibly, I think it also speaks to, how can I put this? You can ask that question in the abstract in the start, but the possibilities for even beginning that research were conditioned by, could I get there? So at one point you had to determine, look, is it possible at all to do gravity measurements in the Central Arctic? And the answer was actually, we've got a station, yes, can do it. Then it moves, you can't do it anymore. But you can't just conjure an ice island into being in the place where you want it. So to some extent, I do think the infrastructure gives affordances there that check the self-correcting nature of the research enterprise and mean that the power is taken out of the hands of the researcher and put back in the hands of the infrastructure. I want to be a little bit careful about saying this is peculiarly a polar phenomenon. You could say that applies in oceanography too, but you can move the ship. You can't move the ship, however, exactly how you want it. But I think in the Central Arctic, the ice and the conditions mean that the role of the affordances provided by the platform are of outsized importance and to some extent have a corresponding impact on denying, we could say, the agency of the researcher here, I think, quite fairly. Yeah. Sorry, that's not quite the question to your answer, I know.
No, I think that has been around, that geography, in a way, I mean, that geographically diverse conditions in a way have an impact on diverging forcings or
Yes.
upon human agency or I mean, there are, yeah.
Absolutely. Geography is not destiny, but that doesn't mean it's completely irrelevant. It does matter. It just doesn't tie your hands. Yeah, I agree.
Also, you could argue in a way that inertia is a matter of degree, right? I think that we are right in using the term path dependency for certain infrastructures. Perhaps you are right in not speaking of path dependency here because the infrastructure was not large enough, right? But if it had become part of a network of consolidated relations within each of the islands or something like that, or within the climate observing network, something like that, then perhaps we would have to talk about path dependency.
Yes, that's true. Yes, it's something as big as the climate crisis and all the global observation networks. Yeah, they're a lot harder to write off. Perhaps the term path dependency does have some validity there, even as a shorthand for the scale of the stuff you would need to ditch and the change you would need to make in order to move. Yeah.
Okay, I think we've reached a point in which we can continue the conversation over lunch, taking advantage of your presence here. I'm also thinking of oceanography. Obviously, it's not only done on ships, also there are drifting buoys, and the solution to those kind of problems has been, for instance, for the Argo program to launch thousands of them, yeah, also because they are cheaper than ice floating islands. But yeah, so great. I think lots of food for thought for everyone. Thanks a lot, Peter. Next month we will be meeting on the 21st of February with Marta Conde, who will be talking about mining. So yeah, the DEEPMED seminar goes on and we go for lunch. Thank you very much, Peter.